Hi, I'm David Weiss from Sam Labs. We make the most entertaining smart toys that inspire every child to easily discover the fun in coding and creating. So what we've done is we built an app-enabled construction kit known as the Steam Kit, which comes with 17 different blocks. So if I actually open that up, you can see we have all these different hardware sensors such as motors, lights, buttons, pressure sensors, tilt sensors, many more, and we also have these cars in here, but then we also have the app side of things to program them. So today what we're going to do is we're going to look a little bit about how to use the app, how to program our own first little project, look at a curriculum that's NGSS mapped, and then see how it fits in, relates with STEAM subjects, but also the Internet of Things and how that's changing our world. Sam Labs was founded in 2014 by Joachim Horn, a mechanical engineer who wanted to give the gift of engineering to children. And we did that through that really fun kit that you're about to see. So why STEAM? Well, science, technology, engineering, arts, and mathematics are the key components to studies of fields that will help us solve problems of the future that haven't even been created yet. Well, how about we think about computational thinking, design thinking, and it's really about problem-solving, exploration, and creativity. And all of that together is transdisciplinary, so a focused approach on problem solving. So education also needs to adapt. We've seen that really those shifts in demands and the skills needed in the workforce are not currently always being targeted in education. So how can we bring something into the classroom that's really enjoyable and fun for kids to build with? So what is the solution? Well, the answer is learning needs to be made fun. So, grabbing my Steam Kit, we're going to take a button and a light. We pair them by dragging and dropping them onto the app, and now we see that they're different colors. Now, in order to create a connection between them, we don't need to wire them or solder them or snap or anything. We just drag and drop that connection. So completely wirelessly, push the button, and we see that the light turns on. Now, what if I want to make that LED blue, for instance? Well, I double click on that and I can select the blue palette wheel, and now we have a blue LED. Very simply, we've created our own blue light. Algorithms or programming. In the app, the software blocks allow you to extend what's happening way beyond just the hardware capability. We simply drag and drop these different software blocks in between, and here's a compare block. I can say if I push the button 3 times, the counter will count it. Only then will it turn on the light. 1, 2, and on the 3rd click, only then does the LED turn on. So SAM is really for the makerspace. It's really for transitioning your coding and robotics into the 21st century. And the way that we've done that is through looking at different projects in the curriculum such as science, technology, engineering, arts, and mathematics. We're really tied together through learning about the Internet of Things. And what is the Internet of Things? Well, the Internet of Things is connecting everyday physical objects to the Internet. It means combining sensors, electronics, software, and the transfer of information to build products that help us connect. Connection is, of course, part of our everyday life and everything that we use, from our phones to the games that we play to the vehicles that we drive. So looking at real-life examples such as out there as autonomous vehicles or a smart home light sensor alarm is something that we can easily build in the app, program, and use design thinking steps to build. I'm going to build a car that drives with the power of the internet. What I do once again, I power those 2 blocks on, and we have to pair them. 2 motors, I'm currently connecting the wheels to them, and once we have the wheels connected, we can see that they will be ready to operate. Now I take the base of my vehicle, and I need a little rollerball that helps us drive around, and I put that in the bottom. There we go. And now I simply put those motors in the back of the car, just like so. They just slide in. And we can also take our Lego connector, such as this one, and we can plug our LED there, and we can put that on the top, very simply, just like that. Now, in order to drive it, we're going to drag and drop those blocks onto the screen, and now we're going to drag in a software block known as the Twitter in. Now, we use one of the logic blocks, and so if we want to power something on and off, we simply drag and connect those. So now here, what is the Twitter in? Well, we can search any trending hashtag, and whenever that is mentioned or tweeted out there in the world, it's going to power our vehicle. So we're going to look for drive. So every time somebody does hashtag drive, it's going to move our vehicle. So now what we see is, whoa, we see now the car is driving itself, and that is all completely due to the power of the internet. Now the car is also very robust, so it keeps driving, and that is a fun way of building a vehicle that can drive itself. So not only have we built ourselves a self-driving autonomous vehicle, but we're also going to look at one of the projects in our lesson plans and also tutorial that show exactly how we can use this in the classroom to learn about math. And we're going to learn about speed. We also produce a range of videos that explain key concepts such as building your own vehicle using light sensors then to trigger the speed. So what is speed? Well, speed is the time that it takes to travel from point A to point B. And exactly measuring that time will give us a nice little calculation. Speed equals distance over time. So we connect the light sensor, and once we've actually dragged that on, we can start thinking, well, actually this light sensor doesn't only clock speed, but it also goes ahead and can be used in a project. For instance, we could build our own alarm system in our smart home. So if I put the light sensor, let's say, inside of the kit, we can see that it goes down to 0 because there's no light inside the kit. If we want that alarm to go off, we simply connect that to our sound player, and I go ahead and I have my sound player right here, and I can connect that. This software block allows us to play sound, so I have a whole bunch of preloaded sounds here, and that means whenever our box is open, we get a notification. We can also customize that block. We can make it play the song that we want. Now, using that light gate as well, we can drive the vehicle, and using that light sensor, every time that it clocks past, it will register a different lighting level, which we can then use to time our speed. It's a very simple project, but can be done in the app very quickly. So using the software to really replicate some of those real-world projects out there and products out there, such as your own alarm system or a self-driving car, is super simple with the kit, and it's a really fun way to explore. Children love playing with it, and we've seen kids build a lot of vehicles, and it's something that's shared across both boys and girls they really enjoy. Several schools also like to build their own lighthouses with the DC motor spinning around. It's a quite creative product, and the fact that it's wireless means that it can be put anywhere, and kids love to play and make their world as they go along with it. The software itself also is great for makerspaces because the way that you design your different circuits or different plans on the app is really a design-led experience. You plan, you make, but you also see the interaction as it happens. So when I change the color of that LED, it happens right away. I don't have to do a sequence of different programming, and it's something that really provokes creativity. And I think that's why SAM is a great option for both the Makerspace, also learning about Internet of Things, but also really bring together that STEAM lesson plan in a really comprehensive way that's fun for kids. Thanks so much. Bye.